So I'd like to introduce Simon Massey now, who's the Software Development Manager at Campbell Scientific Europe, managing the design and development of cloud data services. Campbell Scientific in the UK and covering Europe, their speciality is that they make a lot of meteorology devices. So a lot of the BBC weather forecasts that we see and when we're flying, the data they depend on no doubt will have come from some of Campbell Scientific sensors. And Simon's going to talk today about how they go about connecting their devices to the internet and utilising them with cloud services. So I'll hand over to Simon. Thank you. Thank you.
How many demos have you got?
None. I'm playing it safe. Okay, so just a bit of background. I don't know how many of you know Campbell Scientific or used any of our equipment before. You'll see our logo. We've had the same tagline for years, where measurements matter. Everything we do is based on that philosophy, really. How do we make the best measurement possible? And we'll see how that leads on to where the Internet of Things has started to take our company, based on where we've come from, really. So this is a slide that's nearly a couple of years old now. So we're in our 42nd year now. We're owned by an American company, but we're the European headquarters. And you'll see right back from like 1974, 75 here, we made devices to measure things. Back then, of course, way before the internet and so on, we were making devices that measure something in a lab, on a desktop. It was quite expensive technology at the time, and we were subject to the same things we talked about earlier, RS-232 links, old technologies, still used very prevalent today. Even on our current devices, we've got the same sorts of links. And we've progressed over the years to come up with some of the loggers that we'll come on to talk about now. And we've got much more adept at making this data available. So that's always been our key thing. We've stayed pretty sensor agnostic. We can take most people's sensors, pretty much any really, and read it in one way, shape or form. I know we've talked about taking pulses in. We can take serial data. We can take all manner of different inputs into our devices. And they're very universal in that respect. The Internet of Things starts to become a bit of a challenge to that, as we'll see as we move on. So what we've done is eventually we've evolved these products to be as generic and universal as we can for people. With that in mind, if we just touch on this, our loggers are programmable. So you make the logger do something. So we make the measurement in the device, and then the device has the ability to do something with it there and then. This was very important years ago, where memory was at a premium and you wanted to do some processing so you could maximize the benefits of that memory. Also, transmission technology was at a premium. You couldn't send vast quantities of data over high-speed internet connections like we can today. So with that in mind, we had some very basic programming capability in a thing we called edlog back then. Most people probably have never encountered it. Horrible language that's done on a line-by-line basis with numeric commands. So as we've moved forward, we've needed to improve what our loggers can do effectively. And so therefore, a while ago, we moved to what we call CR Basic now. It is inherently a basic-based language, but it means in here we've got very powerful processors. We can do lots of measurements very fast. In some of our loggers, we can go down to microsecond and sub-microsecond measurements. Great for the research industry, not probably so important to some people for some measurements today. But again, we can do the processing, we do the statistical processing, the analysis, the manipulation of data in the device. And that minimizes the data we've then got to transmit back to somewhere else. And that's always been quite key, because in the past, people might have put something like this out in the field, and they'd have gone along and they'd have manually collected the data, because it was just not possible to go out there and get it over a broadband link like we might now do with some of our data. So inherently, that's where we've come from. That's where some of the design of these devices has basically been born out of. going and having to go out into the field, have a compact flash card on it, something like that, or some sort of proprietary collection mechanism, or going along with a laptop, plugging it in with a cable, taking the data. These devices can record for years without somebody going to them and then going and getting the data in those circumstances. So quite common, we would put those out in remote conditions, put them out in the Antarctic, places like that. They're built for very low temperatures, very high temperatures, and we can go and put the data in there and be confident we can go and get it later on. With more connectivity comes more challenges for us. So over time, we've now evolved our loggers. These are probably the ones people would probably recognise if they know our company now. They're our bread and butter ones. Certainly this black one here has been the CR1000. And they've evolved largely over time because we've got new technologies coming in. We've got things like modern protocols. In the past, we've used very proprietary protocols. People who know us will have heard of PACBus, which is our own communications protocol that always tried to be very resilient over poor communication links, and also used to allow us to create really nice, robust networks with really old, ropey technologies, if you like. But again, much like we've heard in some of the other talks, we are agnostic when it comes to communications as well. So we've had to evolve as we've gone along, and these are just a few examples of how we can connect our devices. So we make lots of additional peripheral items, if you like, for our devices. And you'll see on that previous generation, so here we've got Ethernet modules. So that's connecting to normal networks, internal or going out onto the internet. Satellite connections, we can do Iridium over IP if we want to. Some of the ones we haven't got here, we can do RF radio. Pretty much you name the communications method, we'll be able to attach it into the logger one way or another. But certainly as we've progressed more, and what we're seeing more of is the cellular type connections. So we have modems that we supply with our products now. So that's been traditionally started off as GSM. We've now went to 2G. We've got 3G offerings. We've got this nice, really low-powered 4G modem that we're now starting to bring online as well with our products. So you can start to add all of these onto any of our data loggers and connect them pretty much from anywhere. So that gives us another challenge. What do we do with that data? Because up until now, we've supplied software to people where you give them LoggerNet, for instance, which runs on their desktop PC or a server, and we pretty much let them deal with their data then. So we collect it, we can generate it. We're very adept at generating this data in our devices. It can be from all manner of things. We deal in metrology, structural monitoring, road weather, pretty much you can name an industry will be in there, renewables, monitoring, and so on. So the logger can pretty much do anything you want and produce the data from those measurements that you want. But as we've progressed, the general trend we've got, and I've got two of these here you can have a look at if you want. So we've now started to bring all of this inside a single box again. So the CR6, this would be our more upper end logger at the moment, which is very adaptable. You can make all sorts of things, do different things on here. They're not a fixed purpose on these anymore. You can make a channel, read a pulse, you can make it be an RS-232 port, you do what you like with it. But the key thing here is built-in Wi-Fi now if you want it, built-in Ethernet ports if you want it, larger amounts of data because we can shift larger amounts of data around. So we've got SD card storage to give even longer term storage. And you'll see as we progress as well, this one only launched publicly 3 days ago. So you'll see we're starting to now, because we want smaller packages, we want probably tailored to more specific use as well. We've got lower end loggers coming in. So this one is still adaptable, still programmable with the same languages. There'll be a variant of this that's got Ethernet on it very shortly as well. But these are starting to become a lot more specific to a particular task. So you can start to program these without all the fancy bits that cost lots on there that a researcher might want, or an upper end station like the Met Office work where they want all of these different sensors going in here. you can start to use this sort of end. And we are seeing more where we're taking our technology and we're incorporating it that way. We have, for instance, a water level monitoring device where we've taken the sensor and we've taken the data logging technology and packaged it. And it's in a titanium case and you can deploy it on its own. You mentioned Zigbee, we do sensors in mesh networks and they can talk back to a logger and we can upload that from a single gateway as well. So we are progressing more and more to that fact that we've got to have a logger at one end that can meet the requirements of a research community, and we've got data loggers here that are starting to become application specific as well, as the driver for things on the internet is taking us in that direction. So with that in mind, don't worry with the detail on here. This is a slide I lifted from somewhere else. But basically we're showing here the loggers have gone from that simple serial communication driven by the need to be connected. And we've started to get network capabilities creeping in here now. So IP routing, talking to time data sources, we can do PPP connections for GPRS. All of this stack is built into our devices now. We can do TCP sockets. And the key thing here is we started to move away in many ways from those proprietary protocols that we had to have to get over communications issues and started to move towards more common open protocols like HTTP. FTP saw quite a resurgence with a lot of our customer base and so on. So you'll see we've got lots of commands in our language now to support web protocols as well. We did mention just FTP, so that was a first sort of step. People got to the point where we'd got data on here and it wanted a quick method to just shift data somewhere else. That was sort of a starting point many years ago. So FTP sort of saw a resurgence and it still exists now where people use our equipment like that technology. Obviously it has issues over security unless you start implementing FTPS and so on. Even simple operations like sending it via an email, which was the first step as well for people. Getting the data, and instead of using our typical ways of retrieving data, they were pushing it out as email attachments and so on. But again, the device is doing it. So the device is in control of that. Very straightforward to program once you get used to it, and you can get all of that working very simply. But again, the key point here is you're really letting the customer have to deal with all of that at this stage. We then started to evolve the loggers anyway, so all of this range of modern loggers and the three we saw it before, they have built in things like they've got their own web server inside them now. So you can host your own web pages, you can treat it like a web server. If you've got an IP address to get to it, you'll get a web page, you'll get control of the logger if you want to. All inherently in there, all standard capability. Again, it can operate as an FTP server, and it's got all sorts of different connectivity options in there for talking back to our software and doing a sort of the logger's in control, hello, here I am, pushing some data somewhere else. And then a number of years ago, we took it a step further, and you can now talk to it completely with our web service that's built in there. So using HTTP, all of the loggers talking out can act as an HTTPS client. The CR6 here can have an SSL certificate on it and be a fully secured logger in that respect because it's got a powerful enough processor to crunch all that information whilst doing all its measurements and everything. So you'll see here we've got the web server API, so you can talk inherently to these as long as they're on the internet and you've got, or on a network, and you've got a direct connection to it. You can talk to it, you can manipulate it, you can control it all through a standard protocol now. So we're giving people two options here. So up until that point, we've got all of our devices. For years, we've been putting them on the network, putting them on the internet. The level at which our customer base is putting devices on the internet now is rocketing. You know, there's a huge percentage of the devices that we sell now that are online, effectively in one way, shape or form, which then starts to move our business in a different direction, if you like. So that's the point at which we've now started to take control by offering the service side of it and being an end-to-end solution for people. It's not only do we make sensors of all sorts of different types, from temperature sensors to water level sensors to present weather sensors, ceilometers for measuring cloud heights, you name it, we've got all sorts. We'll take third-party sensors that we mentioned earlier and combine those in as well. We've got the device or devices of varying levels, and in some cases these smart sensors starting to come online, whereby we can get those connected onto the internet. So now, instead of leaving it to you on the desktop and giving you a piece of our software to do it with, which you can freely do if you want that level of control, we have our Connect Global Data Services now. So this is taking it end-to-end to the customer. So the first thing we did was try to solve an issue we have with dynamic IP connectivity. So we have a lot of issues with this with customers with cellular links. So we have our routing service. So with all of our modern loggers, we will supply SIM cards, which like you've got M2M, that work across Europe and across the rest of the world. And we can supply them in any country we choose to at very preferential rates. And we can route them this way, so we don't have to pay for fixed IP connectivity. We can route it through here. You can still get it to our traditional software this way. So if you want to run LoggerNet, you want to run your own server, you want to run we do a web server that runs on there. We do display software you can design, configure, and run yourself in your own hosted environment if you like. Still do all of that. This will still work with it and give you the connectivity. If you've got Android and iOS, you'll find our LoggerLink app that you can get for free. You can use that in conjunction with this. If I put one of these on the web, run it with our router, you can get to it with your mobile phone straight away. And it's all secured through our routing service then. So the SIMs are on our own private VPN. Security is a big consideration here. So the connectivity from the device into our system is private, and then all the data is routed privately and over HTTPS back to your individual device. So that was a way of enabling people to get data into software we've already got now. So then the next evolution we took was Connect itself. So this is a subscription service. So we're starting being the service provider at the other end for people now. It happens to be based on Azure in this case. That gives us big, strong physical and electronic security that we can back up with a big company. So they're underlying it for us. We can say, yes, we meet all of these requirements. Your data is safe. Very key. We are, as I mentioned earlier, we're the custodians of people's data. We don't own their data. We hold it for them. It's their copyright. All the data we store, we provide back securely into a browser, or we can relay it somewhere for somebody. So we could push it via FTP, we could push it by email, we could push it by various mechanisms to third parties on their behalf. So we act as the collection, we act as the relay. Equally, we're storing that for them and acting as a long-term archive of all of their data. With that in mind, we replicate it 3 times inside Azure. So it doesn't matter if the data center in Ireland blew up, we've still got it in Amsterdam, and so on. And we run this all around the world on top of their system, IP connectivity, and we can also use our SIM cards to get back into this securely. So just as this isn't quite up to date, there are some more data centers now, but bits of Connect run all around the world on different systems within Microsoft's Azure system. So it gives us great resilience. It's got service level agreement associated with this that keeps it up all the time. If we do a refresh like we're about to next week to do a major overhaul, it never goes down, it just sweeps through the system updating itself. So again, you've always got access to your data. It's very easy to get that data out to all of your people within your organization or anybody you nominate to give an account to. We let you give out accounts freely. We don't charge additional costs for that. So this is what's rolling out next week, our new update to it. So you'll see we can now start to represent data for people. This happens to be the weather station in Shepshed, but it could be any type of data. But we let you design these yourself, these dashboards. These are live updating. Whatever data rate you choose to call back with from here, typically depending on power requirements, somebody might send it back every minute, every 15 minutes, every hour, every day, it's up to them. We do have one that's running, updating every second, and you get pseudo real time if you want it. So it's really down to what you want to do, your power availability, and all sorts of combinations of that. The nice thing with this, it works across any platform on any device through a browser. So that's running on a desktop, it could be Windows, it could be Linux, it could be a Mac. The same dashboard here automatically flows onto your mobile device, and quite happily show it on mobile if anybody wants to see it after this. But again, I have that and that are the same design. I haven't done anything different. It's just reworked itself to the device size you're going to look at.
And if you had 100 devices remotely, you could show them all on your dashboard.
Yes, you can design any dashboard layout you choose. You've got a whole set of what we would term widgets. And you can drop one of these in, drop a chart in, and it can come from any of the devices that we're collecting for you. Obviously, that lends itself to the fact that with everybody we're adding, we're creating a massive data repository here. So there's great scope moving forward from our point of view that some of the things that have been mentioned before, we've got meteorological data from some providers, we've got flood data from other providers. At the moment, they're quite isolated because that's the way we're operating. There's nothing to say in the future because they're all in the same platform. We can't do more to bring those things together for people. They're all held in a common structure, all against a UTC timestamp, so it's very easy to splice things. It's a very powerful system. We have terabytes of data already that we're holding for lots of customers from around the world. But again, it's very easy for them to start to visualize this, and these are live. And we can do a version of these in what we term kiosk mode, where you can put it out without a password if you want. Give somebody a URL we generate so they can go along and have a look. Or a one-time only password where they go along and somebody has to log in and they can see it, but they don't need access to our system as an actual customer then. And again, our customers are in control of who they give that to. We don't restrict them. This is just an example of further down there. We've integrated maps. We can start to take metadata from here. So it's quite easy to have GPS on these and provide the data of where something is. We have these on ships, for instance, that are moving. You can have that data come back. It can be represented on maps here. So you can start to pull up information and show geographically how it relates to things. And this can only evolve as we progress the service along. So again, it gives you powerful ways of representing data. An example here, just a very simple one where we've got just a couple of stations that we're showing with some data overlaid, but on a full screen view in this case. But equally, you've got access to all of this archive data then. So all the while you're on our service, we're streaming it and we're keeping it. And you can go back and query this whenever you like, in whatever form you like. So here we've got a table. I happen to have pulled a whole host of fields, but it's up to you what you pull. And you can export them. You want to take this out into Excel, do something else with it, you want to pass it to a third party like we do, like a forecaster, for instance, for Metadata, they can then further use that in their forecast models, and we will push it to them for you. Equally, you could chart something, so I can have a look here. This is temperature data for the last half an hour or so, say. But again, you can go and query any point in that historical data archive that we hold. And the final one really is there, just some Windrose showing some wind analysis. Again, it's metadata. But again, it doesn't have to be. It can be any data that we're producing from these devices. So now we can take them end to end, pick their sensors, integrate them with a logger of the appropriate level and capability, attach some form of connectivity to it, typically GPRS or some equivalent to that. Could be on the Wi-Fi, could be on Ethernet and pointing out to the internet, but there's lots of options there. And then get it into the end service where we can do lots of things with it. And that's going to evolve over time. So just really, where do we go next with it? Smart sensors. I know we've touched on it here. We have started to go down that path. You'll always have a researcher who wants that and wants the absolute, 24-bit A to D converter type level of measurement that can do. But then what is a good measurement to somebody? Somebody who just wants a temperature to 0.1 of a degree can get it very cheaply through a smart sensor. So we've got to look at those, but they couple with our service when we're doing that, and we can deliver that to them in a different way. It also gives us this scope for further data processing and longer term analytics. The platform will also trigger alarms via SMS and things like that. So it's quite proactive for some people where they're doing monitoring and they don't want to look at the data, they just want us to collect and tell them if something's wrong. Yeah. And we can do that now. And the scope for adding more and more metadata into these is increasing all the time. We've got people who want to know the history of the sensor we've connected. So what sensor were we using, what was its calibration at the time, and storing that alongside all our data in the cloud, so you've got all that traceability with the measurement. That traceability doesn't have to be on here, it's just coupled up within our system. So there's lots of potential here for the way we move forward, and certainly the connectivity and the Internet of Things and smart sensors and all of that is really driving a section of our business into a whole new area with service provision. Thank you.
Thank you very much. Any questions for Simon?
Question. How do you see your services changing in the near future, in the next few years or so? All the data collection and all that analysis and everything else.
I think data collection is going to become a much bigger part of what we do. Service provision is certainly something we see rivals have started to do, but in a very niche way. We're starting to do this for customers, and I think that will become a larger part of our business in terms of, you know, I'd probably get shot for saying it, but that's not going to be relevant to some people soon, which is why we've got to drive into these markets. It will be relevant to people. It's not going to disappear. You know, if you're researching something, you want that. You know, if you're the Met Office, you need the resolution that's got to drive your supercomputer model that predicts the weather. You can't get away from they want temperature measured to 4 decimal places or something. But that's not everyone. Lots of people want a reasonable measurement, cheaply, and probably at a greater resolution. So I want to put 50 cheap temperature sensors into a smaller area, rather than one expensive logger with one really expensive temperature sensor on it. And driving it into our services is the way that's going to happen for our company anyway.
So do you not see that instead of using a central place for logging everything, people just moving towards having a small sensors?
Yes.
And is that something you're going to do for them, or is that your expertise?
I suspect that that's the way we will go with some areas. So the part of the reason of having Connect is you can have those autonomous sensors without the data logger. It's not quite without it, it's got some history in it, and you are into the territory there where we do have some now where they report every 15 minutes and they've got some basic comms in them, and you could push them back into that sort of service. But I think that'll become wider use than we've got at the moment. And again, but it's one set of our customers, but certainly an area that's growing and probably one we haven't tapped completely yet.
One area that seems to be highlighted today, because we can put a lot of these sensors in a lot of places where we never could, it's going to be quite an issue powering these. I know you've got quite a bit of experience because a lot of your sensors are placed remotely. Are there any changes other than the fact that obviously people are trying to get much lower power circuits, but other than that, the storage of electricity, the management of batteries, solar, wind, is there anything there that is coming to help with sensor technology?
It really comes down to management of that power, and we have lots of these are a lot more careful how they use sensors. And we have, you know, loggers are used a lot to turn sensors off and on, for instance, and only measure them when we absolutely need them, and therefore we're making maximum use of what power. Certainly we've got things like these, we've got charge regulators and all sorts of things in them now to try and help with improving the battery life and making sure they're charged more efficiently. So it's, you know, these are very, I mean, our loggers themselves are inherently low power. You know, if they're not making a measurement, their quiescent mode is, you know, in fractions of milliamps. It's, you know, it's tiny amounts of power draw, and the same with comms. You know, we can bring a modem on and connect to connect and push the data and be off again in, you know, 60 seconds if you like. And so it's all about managing how we use that with our loggers at the moment. I don't think there's any inherent magic bullet suddenly in battery tech that's just about to appear. It's all about how you manage that.
Get the most out of it,
You have all this software solution, offer customers flexibility, how to use it. Do they find it easy to use? Do they ever complain it's not easy to get around how to use the system?
I think there are issues that we've been trying to address, and that new version of Connect is one of them. That launches next week in that form. The one, if you looked at it now, is probably not that easy to use. That's had a radical overhaul based on customer feedback. So that's quite nice. It's very straightforward, and if somebody comes to use it, there was that single bar down the side. It's very easy in that respect. We are doing a lot of work at the moment in simplifying how you deploy these things, compared to, especially when we're coupling up to services like that, but that's ongoing work at the moment. But yes, it's a big focus for us in terms of usability for the end user. And certainly with these services, there are things we can do, and we're talking about that. It's not public knowledge at the moment, that means it would make it easier to configure that into a service like that than it would be to take it into, say, a piece of normal desktop software or something like that.
Any questions for either Simon or any of the other speakers?
I think it's interesting, sat here, sort of coming from the other side, from more the network side. The network is kind of assumed to be there. It's infinite. We're going to put these chips on. When you talk about GPRS and GSM technology, do you ever concern that somebody will one day turn off GSM?
And we do. Yeah, well, we've done that a lot. We know GSM's on its way out in a lot of areas, and we actively have pushed people away from it now, and we move them along. That's the key with this, because it's not integrated into the logger. We can change the modem and we can move them onto GPRS, or we can move them onto 3G, 4G, whatever, without getting rid of this. So we do. GSM we really don't sell now and haven't done for some years. Right. The odd person will ask for it, but it's rare, especially as you move into some places in Europe and the rest of the world where it's already probably gone for the best part. I mean, we can still get it through our supplier, but you wouldn't go straight to Vodafone and they'd want to sell you a GSM connection unless you're a really big outfit or something nowadays.
But take that further, the things that 5G promises,
yeah.
Is there anything there that you see that you're going to exploit in future, like the lower latency, the narrower band LTE?
And it's every time we get, I mean, that modem that we were talking about there is the new Sierra wireless one, is the first one that pulls under 1 milliamp, I think, in normal usage, which is a key thing when you're coupling it with our tech, where we're known for low power. Yeah. So up until now, 4G has been limiting because it's got a big power draw. That's the first 4G one we're actively selling in conjunction. People have put them on. You can plug all sorts into these. Certainly as 5G comes along, because we've put things like Ethernet ports on here, no longer has the logger got a limiting interface. And the software that's in here, we're in control of our own operating system. So, we do at least one a year. Sometimes we're churning it twice a year. And there's always new features coming in here, or new ways to deal with the IP stack that's in here and the interfaces we've got. So generally, as we've moved forward, the device always keeps up with the network technology, because there'll always be somewhere we can plug on. It's part of the reason we get asked quite a lot, why don't you put a modem in here?
Right.
And we could. This one happens to have door-to-board capability. That's where the Wi-Fi bit comes from. You can have it with or without Wi-Fi. We've looked at having a door-to-board in there that does, 3G, 4G, so on. And we can do it, but we've got to do several versions for around the world. We've got to recertify it because it's in our package then, rather than in somebody else's that's already been certified. And then you're fixing somebody to that for the lifetime of the product, which with a modem that's external, you can take it off and replace it without replacing that. So we tend to keep up with technology. And we would get often asked, the Ethernet ports on these are only 100 base. We don't bother with gigabit. It's pointless because the throughput from here and the amount of data you would want doesn't matter to us at the moment. For years we stuck on 10 base, and because it wasn't an actual need for us to go. People make the assumption just because it's there and it can go faster that we need it on here, and we don't. But I don't see things like 5G and so on being a limiting issue for this.
Right, so it's not going to bring anything. It's not really going to take anything.
It will improve things from our point of view in terms of if you get a 5G modem on here and you've got the power to run it and you plug it into here, you're going to get data quicker up to there, and we can probably churn data faster and push it more often and those sorts of things. But in terms of connectivity, we'll be able to attach it to these things.